Hello there, physics class. Let's talk a little bit about thermal energy today. First of all, thermal energy is going to flow always from a hotter, something that's warmer, into something that's cooler. As that energy begins to flow from one to another, that is really what our heat energy is all about. It's measured in joules. Okay, Q is the variable that designates that. If it's positive, the energy came into the object, and if it's negative, it has gone out. And that motion of the fluid is caused by temperature differences, and that's called convection. Okay, so if the energy is transferred by electromagnetic waves, it's called radiation. Okay, so radiation isn't always just that thing that we're thinking about, like radioactive or scary or anything like that. It's just a transfer because of electromagnetic waves. If you look on page 279, there's a chart of values that's called specific heat, and it is material based. So in other words, what something is made out of determines how much heat has to be added, how much energy has to be added to 1 unit of mass to raise the temperature 1 unit. So because water has such a high specific heat, it's good as a coolant because it takes a lot of energy coming out of something else in order to heat it 1 degree Celsius or 1 Kelvin. So it's very good because if you've got something very hot that's put into it, it can take a lot before it actually begins to completely heat. And so it can absorb a lot of that energy and keep something from overheating. We have an equation that we're going to use. Q is the heat gained, M being the mass, C being that specific heat value, and delta T as being the change in temperature. It doesn't matter if the temperature is in Celsius or Kelvin because as we said, the temperature scale is the same. So we're going to run through just one example, and then you're going to work on practice problems 5 and 6. Okay, so first of all, we've got a 4-kilogram block of iron heated from 295 to 325, and we want to find out how much heat has to be added in order how much heat had to be transferred into the iron, the block of iron, to have that happen. So when you look on the chart, you have to be given the specific heat value. And so on that chart that I told you about, you can find all those values for specific heat. You're going to look up the material, and that's going to give you this particular value, and it tells you how much energy it takes to raise it 1 degree. And then you do the change in temperature and then multiply times the mass, and it will tell you how much heat has to be gained for that. So that should be enough information for you to be able to do problems 5 and 6. So please go ahead and do them. I know it's short today, but that's okay. We don't need to do too terribly much. God bless you all, and I hope that you have a really great day.